Hey everyone, I'm just going to show you real quick one of my favorite components ever. As you can see, I have a little circuit built just to showcase this component. On the left, we have a current limiting resistor, which limits the current through the circuit to just a few milliamps. And on the right, we have what's called a Zener diode. Now, the point of a Zener diode is to start conducting current through it at a specific reference voltage. So normally, it will function as a proper diode without conducting current. As you can see, I have it hooked up to my power supply in reverse bias. The black bar on the left of the diode is the cathode. That is the negative side of a diode. So by hooking up the negative lead of the power supply to the right side, the side without the bar, we've connected the power supply to the anode of the diode. So it is now in reverse bias, which means that it will not conduct any current until it's hit its reference voltage. Now, the reference voltage of this diode is right around 4.7 volts. And I'll be able to demonstrate that to you using my power supply and a multimeter. Now, what I'm going to do is I'm going to connect the leads of my multimeter and hook them up to show the voltage drop across the Zener diode. You can see what I've done here is hooked up the positive lead to the cathode of the diode and the negative lead of the multimeter to the anode. Now we're skipping the resistor because we are simply measuring the voltage drop across the diode, not the voltage of the power supply as a whole. As you can see, it is currently set to 0 volts and we're reading roughly 0 volts across the diode. It's not generating power, it's just some residuals. Now, I'm going to be able to turn on the power supply and you'll see the voltage rise on the multimeter. As mentioned before, this is a 4.7 volt diode. So when we raise the voltage to 1 volt on the power supply, we're going to read almost exactly 1 volt on the multimeter. This is because the voltage drop across the diode is exactly the same as the voltage of the power supply. This is because we haven't reached the Zener voltage yet, and the diode is dropping all of the voltage of the power supply, not allowing any current to flow. You can see the same behavior occurs at 2, 3, and 4 volts. Now, as we get closer to the Zener voltage, you're going to see that these voltages slowly drift apart. As we continue raising the power supply, the voltage drop across the Zener diode will remain close to constant. As you can see, we're putting 10 volts across it through the power supply and reading a voltage drop of around 4.55 volts. This is significantly less than the current that we were seeing through it before, or the voltage that we were seeing through it before. Now, as I continue to increase the current, or as I continue to increase the voltage, you're going to see the Zener diode roughly stabilizes around 4.7 volts, which is the Zener voltage. So as you can see, we're using it as a voltage clamp to limit the voltage drop across it to roughly its Zener voltage. Regardless of the input voltage, as long as it is sufficiently above the Zener voltage, we're going to be reading the Zener voltage across the diode. This can be used easily for measurements in series with an op-amp or other components. I hope this was a fairly simple explanation, and if you have any comments or suggestions, please leave them in the comments below. I hope everybody has an amazing time, and I hope you guys create some amazing projects. This is really awesome, and I hope you guys have a great day.